Okay, so do an example similar to number 3 off of our shear and moment diagram quiz, which is quiz 6. Um, we'll sketch this out. Oops, I got this. So let's just do a rough sketch. We'll go 300 pounds per linear foot. Let's do a eight-foot overhang with R1 here. We're going to do a point load, 500 pounds out here. We're going to come in here at 6 feet and do another concentrated load of 1,200 pounds. And we'll go here at, I don't want to be too similar to what we have. We'll do 6 feet from this end. And we're going to do 800 pounds. Now we're going to have a 30-foot span across there. So step 1, of course, is to find our reactions. So the sum of our moments, we've got 500 pounds at 8 feet. That's going counterclockwise, so that would be positive. We have 1,200 pounds. Of course, our center of rotation is right here at R1. 1,200 pounds at 6 feet, but that's in the negative direction. 800 pounds, also in the negative direction, at 30 minus 6 at 24 feet. Then we have our distributed load. That's 300 times 38. Which is 11,400 pounds. At half of 38 would be 19 feet, so that would be at 11 feet from the center of rotation. And of course, that's also going to be in the negative direction. And to that, we're going to have R2 at 30 feet. Adds up to 0. So let's see here. We'll have, come on, 500 times 8 plus 1,200 times 6 plus 800 times 24 plus 11,400 times 11. And then divided by 30 to get R2. 4926. Okay, so let's so we got 4926.67 is the reaction there, and hopefully we will do minus the 11,400 minus 800 minus 1,200 and minus 500. 8973.33 here. Okay. Next, you need to do a shear diagram. I'm going to shrink this down so I can see what I'm doing. So here's a shear diagram. Starting on the left side, first thing we encounter is a downward force of 500 pounds. So we're at negative 500 pounds there. And then we have the distribute between that and the next concentrated load of R1, we have a distributed load of 300 PLF. So it goes down 300 pounds every foot, times 8 foot would be 2,400 pounds. So negative 500 minus 2,400 would be negative 2,900. So it goes down to there. Then R1 of 8,973.33 pounds going straight up. Negative 2,900 plus 8,973 is 6,073.33 pounds. And it proceeds to slope down at 300 PLF for 6 feet, so 1,800 pounds. Bringing it down to 4,200. and 73.33 pounds here. And then straight down at 1,200 pounds, bringing it down to 3,073.33 pounds. Sloping down at 300 PLF now for 18 feet from here to here. That's 18 feet. Is going to take us down 5,400 pounds. So 5,400 pounds is going to take us down to a negative 2,400, somewhere down here. Now these slopes here, here, and here should all be the same because they're all 300 PLF. Mine didn't get to be exactly the same, and I won't be picky if yours aren't exactly the same, but they should be relatively close. So negative 5,400 pounds puts us at negative 2,326.67 pounds. 800 pounds straight down puts us at a negative 3126.67 pounds. And then for another 6 feet, sloping down at 300 PLF, for another 1,800 pounds, puts us at 4,926.67 pounds negative. 4,926.67 pound reaction brings us back to zero. So there is our shear diagram, completely closed back to zero. Any questions on the shear? Now it's that shear diagram that allows us to create the moment diagram. Now the first thing I'm going to do is I'm going to find the distance from here to here on the shear diagram. That's just going to be found by taking this value, 3,073.33, and dividing by it, so 100 PLF is the slope of that, or not 100, 300, sorry. So divide by 300 is 10.24 feet. So, on to the moment diagram. The moment diagram is going to be kind of tricky here because we're going to deal with a lot of curves. And when we're dealing with curves, really it should be way stretched out vertically, but we just don't have that kind of room to do it without going off our paper to make the curves fit. But anyway, we'll start off here. On the left side, the shear diagram is negative, which means the moment is decreasing. Well, the moment starts at 0 at the end of the beam. So from there, it's going to decrease. Now, the value of the shear diagram is the slope of the moment diagram. So here it's negative. Here it's more negative. So the slope is increasing. So it starts out sloping negative, but it gets more negative with its slope, like that. A slanted line on the shear diagram becomes a curved line on the moment diagram. Well, that just means that if it started out right here, that means it would start out perfectly flat, and the slope would start at 0 and come to curve down. Since that's at negative 500, it means it doesn't start out flat, it starts out already sloped. Now, the value right here is just the area of this trapezoid. So that's going to be 500 plus 2,900. Times divided by 2 and then times 8 feet. So 500 plus 2,900 divided by 2, that's the average of the bases, and then times our 8 feet of height, is 1,360 foot-pounds. Oops, sorry, 13,600, I should say. The 8 feet was this distance here, from here to here. So this will be 6 feet, that's 1024. This was 18, so this will be 7.76, and then this will be 6 feet here as well. So now the shear diagram becomes positive, really large positive. So the slope here is really large positive. The value of the shear diagram gets smaller, so the slope gets smaller. I'm going to find this area here to see if we get above 0. So we got 6,073.33 plus 4,273.33 divided by 2, averaging good. Because this is the trapezoid here going up, so you're going to use this value up here, not the one down here. It's the one that defines the corner, the vertex of the trapezoid. So divided by 2, and then we're going to times 6. 31,040 basically. So we're definitely going positive here, way positive. So we start out steep slope, and it's a little less steep. So a negative 13,600 plus 31,040 is 17,440 foot-pounds. Now it drops here, so the slope gets less, but it's still increasing. So from here it's lower slope, but it is still increasing until it gets to right there where it's 0, so the slope is 0. So it's flat right here. Right up here it should be flat, going to flat. So to find that value, it's going to be the area of this triangle here, which is the 3,073.33 times 10.24 divided by 2. Here, because it's above 0. Once it hits here, now that the shear is below 0, now it's going to start to decrease. But as long as the shear is above 0, the moment is increasing. So we're adding 15,735.45 to our 17,440. Putting us at, obviously this is not done to scale. Something's wrong there. That don't look right. I guess it is. It has to be, doesn't it? So 33,000 here. 33,175.45. So obviously my scale is a little off here. That point should be way up here somewhere, but I didn't have room. Now from here it's negative, so it's going to go down. So we're going to go down by what this triangle is. It's going to start sloped at 0 and slowly curve down to that point. That should be straight below there. That is going to be, is it 2326.6? 2326.67 times that 7.76 there, divided by 2, 9,027.47. So we subtract that from the 33,175.45. Gives us basically 24,148. So that's 24,148 foot-pounds. And then we have this final trapezoid here, which is going to take us, hopefully, take us back down to 0. That area better be close to 24,148. So 3126.67 plus 4926.67 divided by 2, and then times 6. 24,160, that's close enough. 24,148, 24,160, close enough. We'll call that 0. What do you think? Loads of fun? Yes, that is recorded. Yes, it is. And for the right price, I'll share the recording with you. So you have